let m and n be positive whole numbers such that root m minus root n equals root m times n minus 5. What is the sum of all possible values of 3m plus 2n? So this one, we can see that it's very similar to what we all know as Simon's favorite factoring trick. And if you want to review that one, x minus y plus 1. So it looks something like this. You'll have a product of two different variables and then minus the separate variables and then some constant. And usually that's what we see here, except it's under square roots. But that shouldn't matter at all, because we can see that if we split mn as root m root n minus 5 equals root m minus root n, we say that, okay, this is just very analogous if we let x be root m and y be root n. We'll work in square roots for now, just so we can get used to it without needing to do some substitutions, which do waste a bit of time. We can just shave off that time by kind of imagining our head that we're doing this substitution. So we'll subtract, move everything to one side. We'll factor as so, but then we have to adjust the constant. We see that we want to factor this into root m minus plus or minus some constant times root n minus plus or minus some constant. We need 1 here because the coefficients of these root m's and root n's are 1. This root m is negative, so on the root n side is minus 1, and then on the root since it's root we need root n, the root m side will have plus 1. Multiplying together, we get a negative 1 on both sides. So if we subtract minus 1 and then factor like this, we get 5 minus 1 is 4. We see that these need to be integers because m and n are positive whole numbers. And by definitions of square roots, you can't have -1, -4, -2, -2, -4, -1. You can verify these yourself, but then you'll get square roots to either be 0, to equal 0, or some negative number, which can't happen at all because that violates the definition of square roots. So we're actually going to have only the positive roots here. This first case won't work because root m is 0, so only these two work. So if we solve, we get m equals 1, n equals 9, and here we get m equals 9, n equals 4. But we're actually not done yet. This is this is a little tricky problem, because if we look at the case where m equals n, seeing here that these are actually just radical conjugates. These are just generalized radical conjugates, but these are actual conjugates if we set m equal n. And so if we have root m plus 1 times root m minus 1 is 4, we see that we get m minus 1 is 4, and so m is 5 equals n. So we actually have 3 pairs. We have mn equal 1, 9, 9, 4, and 5, 5. And so if we have 3m and 2n, we get 3, 18, 27, 8, and 15, 10. And if we add all these numbers together, because these are just all possible values of 3m plus 2n, we get 21 plus 35 plus 25, and that equals 81. And 81 is our final answer. And we're done.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.